Hey students, this video is going to go over gram to gram conversions and other types of conversions in stoichiometry. So what we want to do is remember some of those conversion factors that we were using last semester, such as 1 mole is equal to the molar mass, or 1 mole is equal to 6.02 times 10 to the 23, and that's going to be atoms, molecules, or formula units, depending on what substance we're talking about, okay? But we're going to kind of do some problems that involve all of those different things. So when we're going to be doing this, we are going to start, of course, with our balanced chemical reaction. I want you to circle what you're given in your reaction and write what you have about that above the reaction itself. You're going to box what you're looking for and write what that's going to be above the reaction. This is going to help you to focus your stoichiometry sequence, letting you know where to start and where to stop. You're going to use that dimensional analysis process that we've been using during mole conversions to help you to set up your problem. So let's take a look at this reaction here. How many grams of water are produced when 25.03 grams of iron 3 oxide are reacted with an excess of hydrogen gas? So we're going to circle what we're starting with, which is that Fe2O3. We're going to write how much we have above that. We have 25.03 grams. We're going to box what we're looking for, our water. So when we start our stoichiometry sequence, remember, we're always going to start by writing our given over here. We're starting with 25.03 grams of Fe2O3. When you're doing stoichiometry in any kind of dimensional analysis, whatever unit you're starting with, so in this case, grams of Fe2O3, that unit has to go down here at the bottom. Make sure you're writing your unit, the gram, and your substance, the Fe2O3, because we are going to be switching in the middle of our problem. It's really important to keep track. So if you have grams in your conversion factor, you're going to be using the molar mass from the periodic table. So you're going to add up 2 irons and 3 oxygens to get 159.7. Now, the molar mass of a substance is always going to be equal to 1 mole of that substance. I just want to point out here that this 1 mole is not because the coefficient of the Fe2O3 is 1. The 1 here is because you always use moles when you have molar mass on the other side of your conversion factor. So again, whatever unit you start with, that unit has to go down here at the bottom of your conversion factor. When you're doing stoichiometry, whenever you get into moles, then you go into your mole ratio and you use the coefficients from the balanced equation. So now we're going to use a 1 because we're using the coefficients from the reaction itself. We're looking for water. Remember, it says up here, we're looking for water. So we're going to have moles of water up here, and we're going to put a 3 because that's how many, what the coefficient of the water is in our reaction. Now we're looking for grams, so that means we have to keep going. If we have moles of water up here, we need to put moles of water down here. You can only use the coefficient 1 time, and you always use the coefficient when it's coefficient over coefficient. So now we have to go back to using our 1, which makes sense because we're looking for grams of water, and we know we're going to have to put our molar mass of water up here at the top. So when you enter these into your calculators, again, it doesn't matter how you enter it. If you want to put everything in the top and multiply across the top first and then divide across the bottom. If you want to work left to right like I do, I put 25.03 divided by 159.7 because it's in the bottom, times 3 because it's in the top, times 18.02 because it's in the top. And I don't have the answer here, but if you plug that into your calculator, you can figure it out. And I'll put the answer so that it's online for you guys. In this example, how many grams of barium chloride would be needed to produce 33 grams of iron 3 chloride? So we want to make sure that we balance our reaction. Okay, you can already see that I've circled what I'm starting with and I've boxed what I'm looking for. So I want to balance this reaction. There are my coefficients, okay? I'm starting with 33 grams of the iron chloride, and I'm trying to find grams of barium chloride. So see, it doesn't matter. We don't have to start with the reactant and end with the product. We can start anywhere and end anywhere in our stoichiometry sequence. So what's the first thing that we're going to start with, and what are we going to write over here? Remember, we're always going to start by writing our given. We're starting with 33 grams of FeCl3. We have to match our units down here, so it means we have to have grams of FeCl3 down here. So if I have grams of FeCl3 in my conversion factor, that means I have to use the molar mass, and I have to look at the periodic table. So I'm going to have 162.2 grams of FeCl3 down here. The molar mass is always equal to 1 mole on the top. Oops. So I have to have 1 mole on the opposite side of the conversion factor from my molar mass. Since I've got moles of FeCl3 here, that means down here at the bottom of this next conversion factor, I need moles of FeCl3. I look at my reaction now, because anytime I'm in moles, the next step is going to be to use the coefficients from the balanced reaction. So that means I need to have 2 moles of FeCl3 down here. I'm looking for the barium chloride, so that means I have to have moles of BaCl2, up here, and my coefficient is 3. I'm not done, because according to my work up here, I'm looking for grams, so that means I have to have moles of BaCl2 down here. I've already used the coefficient. Remember, I only use the coefficient one time when it's coefficient over coefficient, so I have to use moles here. And I'm looking for grams of BaCl2, so that means I go to my periodic table, find my molar mass of BaCl2, and put that here. Now when I plug this into my calculator, I've got 33 divided by 162.2 because it's in the bottom, times 3 divided by 2 times 208.23 because it's in the top. All right, so plug that in and see what answer you get. All right, this example here, how many moles of Fe2SO4 would be needed to react with 115 grams of BaCl2? You can see that we are using the same reaction from the last question, so it's already balanced. I've circled what I'm starting with, the barium chloride. I've put how much I'm starting with right there by the reaction, and I boxed what I'm looking for and put what I'm looking for. I'm looking for moles. This problem is going to be a little different than the last two that we did. The last two were both grams to ending up with grams. This one, we're starting with grams and we're ending with moles. So we want to pay attention to our units. Remember, whatever we're starting with, that's the first thing that we put over here. We're starting with 115 grams of BaCl2. What unit am I going to put at the bottom of my conversion factor? I'm going to put grams of BaCl2. How many grams of BaCl2? Well, I look at my periodic table and find my molar mass, which is the same as the last problem, 208.23. What goes on the top of molar mass? 1 mole goes on the top of molar mass. Notice this is not a 3. The coefficient of BaCl2 up here in the reaction is a 3, but this is not a 3 because molar mass is only equal to 1 mole. This unit here, moles of BaCl2, goes here at the bottom so that I can cancel it out. This is where I'm going to use my coefficient and put that coefficient right here so that I can switch from moles of BaCl2 to moles of Fe2SO4. How many moles of Fe2SO4? I'm going to have 1 because that's the coefficient. Now here's where we have to be careful. We're looking for moles in our problem. I've got moles at the top. Remember, you end your dimensional analysis whenever the units you're looking for end up at the top of your dimensional analysis. So I stop right here and I do not keep going. So when I plug this into my calculator, I'll have 115 divided by 208.23 divided by 3. I want to make sure I have 4 sig figs for my answer. All right, this one again is a little bit different. How many molecules of oxygen would react with 117 grams of propane? So first I want to start with our balanced reaction. I can see that I'm going to need a 3 in front of the carbon dioxide so I can balance out the carbons. I'm going to need a 4 in front of the waters to balance my hydrogens. And that means I need a 5 in front of the oxygen to balance my oxygens. I'm starting with, 175 grams of propane, and I'm looking for molecules of oxygen. So here's my setup. What's the thing that I write over here on the left side, starting out my problem, my given? I'm starting with 175 grams of C3H8. What unit am I going to put down here at the bottom of my conversion factor? I'm going to put grams of C3H8. How many grams of C3H8? I'm going to look on my periodic table. I'm going to get my molar mass, which is 44.11. What is equal to the molar mass? What am I going to put on the top? 1 mole. 1 mole always goes over molar mass. Now I've got moles of C3H8 up on the top. That means I have to have moles of C3H8 down here at the bottom. What number am I going to put with this? I'm going to put a 1. Why a 1? Because that's the coefficient of the C3H8. I'm looking for molecules of water, so that means I have to have moles of water, or sorry, not water, oxygen. So I have to have moles of oxygen up here on the top. I'm going to put 5 moles of O2. I can't put molecules of O2 here because I'm not there yet. I always have to have the coefficient over the coefficient. So that means I have to do another problem. So I have to have moles of O2 down here at the bottom, because remember, whatever unit I have at the top needs to go at the bottom so I can cancel it out. I've already used the coefficient, so I'm going to use 1. Now here, remember, I'm looking for cules, molecules of O2. I'm not looking for mass, so I'm not going to get the molar mass of O2 from the periodic table. If I've got molecules and I'm looking for molecules, that means I'm going to use Avogadro's number, 6.02 times 10 to the 23 up here. Okay, so then when I plug this into my calculator, I would have 175 divided by 44.11 times 5 times 6.02, second E, 23 up on the top. I'm going to have 3 sig figs for my answer so that I can end up with the correct number of sig figs that I need. Last example here, I'm going to use the same equation, and this problem is written in your packet for you guys, but I'm starting with 1.57 moles of C3H8, and I'm looking for molecules of water. So the number that I start with is going to be that 1.75 moles of C3H8. Now, whatever unit I'm starting with, that unit has to go at the bottom. Just because of the way I have this set up, I'm going to put it down here because that's where it says molar ratio. So I'm not going to use the molar mass of propane here, the C3H8, because the question doesn't say anything about the mass of the C3H8. If I'm starting with moles, the first step is to use that mole ratio from the balanced reaction. So I'm going to have 1 mole C3H8 down here, and I'm going to switch it to moles of water using the coefficient of the water up here on the top. I go straight from starting with moles into that mole ratio. Now, I've got moles of water up on the top. I got to get rid of moles of water, so I'm going to put that on the bottom. I've already used my coefficient, so I use 1 down here. I'm looking for molecules, so what number goes with molecules? Am I going to find the molar mass of water? No, I'm not going to find the molar mass of water. I'm going to use Avogadro's number. So then I would type into my calculator 1.57 times 4, because it's in the top, times 6.02 times 10 to the 23, so that I can get my answer, and I'm going to round it to 3 sig figs. All right, so I'm going to have you guys try this one on your own. Here are the answers for these 4 problems. I want you to give it a try. The balanced reaction is already provided for you, so this is just based on stoichiometry, several different kinds of stoichiometry sequences, so it's really important to pay attention to your units so you know where you're starting and where you need to stop. So as you're giving these stoichiometry sequences a go, if you have any questions, just let me know so I can help you guys out. Thanks.